Computer. So welcome everyone. Appreciate you being here with us. Today we've got a special treat for you. We're going to talk about we're not, but we're going to let Kyle and Graham Porter talk about the Virtual Robotics Training Academy. And this is a group that I was introduced to through Cisco and doing some meetings and looked at it. And they've got a really neat product and a really neat suite of things that are extremely useful. And so I'm gonna let them go over it, but especially the simulators are things that we haven't seen before really being put into play the way they're being put into play. So I will turn over here in just a second. I do have a couple little things I want to mention to you. Obviously, all of you are Cisco Academies. We were talking about supply chain. I can tell you right now, if you think you're going to order any equipment this year, you better order it today. You're not going to be able to spend your money because we literally have switches that we have ordered in July that may be here in December. We're looking at 150 to 160 day lead times on routers and switches. So you know how we're all state entities and we like to wait till the last minute and they come and say, well, spend $50,000. You're not going to spend that money and get that equipment on campus if you wait till March to order it. Quite honestly, you might order it right now and still not get it by June of next year. It is that insane. And it's everybody. It's not just Cisco. We're trying to get machines from Dell and from other vendors, and it's just across the board insanity with trying to get equipment. So if you think you're going to get equipment, go order it today and get it as soon as you can, because that's a big problem. With that though, I'm going to turn it over to Graham and Kyle. Kyle, I'll let you start, just kind of give a little overview or however y'all want to do it. Sure. Graham, you can share your screen and you can share PowerPoints directly from your machine, so you can do that. But I'll let y'all just take over from here, and we're here to support and help. And if you need anything, we are recording, and I will send this out after the meeting to everyone on my list. So it's going to go out to all 800 or so of our folks that are on the list. So, but with that, I'll hand it over to Kyle and Graham.
Okay, thank you, Kelly. My name's Kyle Boyko. I'm here on behalf of the Virtual Robotic Training Academy, VRTA Online. This is a proprietary built learning management system meant to teach STEM by doing, using simulation. It was a pandemic response. Graham and I are based in Northern Ontario, in beautiful northern part of Canada. The truth is, accessing advanced STEM training and technologies when everyone is using a Chromebook has created a number of challenges. Our organization created the VRTA to, one, provide all students and learners with a level playing field. We focus in Python programming, robotics and automation, and cybersecurity powered by NetAcad Cisco. Graham Porter will have the responsibility to not only take you into the learning management system, but specifically give you a demonstration on how we start out our learners with zero background in programming and programmatic thinking, and then we show them how to apply it, and then we give them the ability to really move into some exciting experiences with Cisco Net Academy. Thank you very much, everyone, for again the opportunity and your time today to allow the VRTA Online to present. And we single-handedly wouldn't be here without Kelly's leadership to provide us this forum to share it with you. So thanks very much. I'll turn my video off. That'll be enough of me smiling and talking, and we'll turn it over to Graham.
Thanks, Kyle, and good afternoon, everybody. I will see if I have permission to share my screen here. I'll try and keep the basic song and dance to about 10 minutes and then leave time for questions and discussion, whatever we can do to help. So the site is vrtaonline.com if anybody wants to review it on their own time. As Kyle said, this is a learning management system that we have developed specifically to focus on STEM skill development through simulation. So learning by doing. So I'll show you a little bit of examples of how that works across our kind of three major areas. We'll normally start with programming. We have about 70 challenges on the system now, and covering those 3 areas, and we're constantly adding new ones. I'm going to start with Python because without at least basic programming, the fun stuff is hard to do. So this is an example of one of our challenges. It's a short course that teaches a specific skill or allows a user to solve a specific real-world problem. It's heavily video-based. We can source videos from anywhere, but we usually develop our own to keep them short and to the point. And the Python course assumes no prerequisites. So I've never written a line of code in any language, and starts from there. Obviously, students with experience can kind of race through the early stuff, but it's designed to make sure that nobody gets left behind here. So the videos explain all the concepts that are involved, and then we can start to get into some of the interactive stuff. If any of you have seen solutions like Code Academy, you'll notice some similarities. Everybody's converging on ways to interactively teach code. Under the hood, we have our own custom software that's a generation ahead of what Code Academy is doing. So this one, performance-wise, works really well. So we explain why we're here and why we care. We have a specific assignment that the student is asked to do. And this, running in a browser on a Chromebook or anything, is real Python. So I'm going to run it. This is getting parceled off into the cloud where the language is actually being interpreted. The output comes back along with an assessment that says, okay, it didn't throw a Python error because print is valid Python, but hello world is not what the answer to this particular exercise is. So we can do some assessment. The students can work on this on their own. If they don't have a teacher who can teach Python, they can work on their own. If they're in a blended environment where the teacher, there might be a long wait time to even ask the teacher a question, they can proceed on their own. And we go step by step by step through more and more complicated topics. That's module 1. By the end of module 7, which takes a total of about 10 hours, they can work with variables, functions, and loops. And by the time they can work with loops, they've achieved functional literacy. So, I mean, all programming languages are basically variables, loops, and some window dressing. So, and so with about a 10-hour time investment, which, you know, a student could do in a weekend, they can get over that initial hurdle. Everything we're seeing, not only in high school, but in post-secondary, is that the problem with getting programming literacy into the general population is at the beginning of the process, not the middle or the end. So we routinely talk to universities that report that, you know, the drop rate in their intro to Python class is north of 50%, but it's all in the first 3 weeks. Anybody who can live past that can get over the hump. And so what we try and do is make the beginning of this process as easy and engaging and interactive as possible to get students over the barrier of thinking that programming is for other people. So after about 10 hours, the students have functional knowledge of this, and they start to ask, okay, well, what can I do with it? And now we move into the second pillar, which is we're going to use some of those tools and apply them to a real world problem. So this is a robotics challenge called Pick and Place. It uses a 3-axis robot arm to solve a word problem, which is to write a program that instructs this arm to pick up these 3 blocks, put them in that container, and not throw the blocks across the room, because in the simulator, friction, inertia, and gravity are all factors. So the video up here explains the concepts. What are the 3 axes? What's a radian? And the video down here kind of talks students through solving word problems programmatically. Like, what's the thought process? What's the process of trial and error? How do we break this into components? A little bit more text, a glossary of functions that this robot understands. And now, assuming I don't have a Bill Gates moment, we'll get to the magic. So what I'm doing here is I am spinning up a virtual machine in the cloud. I'm installing an image of the simulation environment. I'm hooking all of this up to the user's front end, and I'm checking to see whether this user has worked on this challenge before. And if so, I'm loading up the most recent version of their saved work, and I'm doing that in plus or minus 8 seconds. So what we have here on the left is Gazebo. This is an industry standard tool for visualizing robotics. On the right, I have a Jupyter Notebook. This is an industry standard tool for programming in the cloud. And hooking the two of them up in the background is a protocol called ROS, Robot Operating System. This is a universal translator protocol championed by AWS and others that's designed to separate the hardware and the software layers in robotics. So right now, I'm going to write code that's going to control pixels. But if I wanted this to control the physical version of the 3-axis robot, I drop down into ROS, change 2 lines of code, and now instead of controlling pixels, it controls voltage. So I'm going to hook these 2 windows up together. and then I can start giving it instructions. Robot arm moves. I close the gripper closes. And so if I'm a beginner student with no experience in this, I can program this like a turtle and just go line by line by line and brute force my way to solving this problem. If I'm a little bit more intermediate, I can start to use the things I've learned about functions and loops and squash this to, I can squash the code size down by about 80% and make this easier to debug and to optimize. And what we usually find with students is after about an hour, everybody can basically make the thing work, and they can easily spend about another 3 productive hours optimizing it, making it work better, making it more error tolerant, starting to look at what their neighbors are doing and start to make improvements there. And this is an example of something that anybody who wants to go into automotive, anybody who wants to go into warehousing or logistics, the human arms are getting replaced with 3-axis robot arms. And so this puts students on a path to a number of real career opportunities, and they can actually start to demonstrate that they can solve real world problems rather than kind of academic only or hypothetical problems. And what this leads to is, as the students are completing these challenges, they're building up a CV. So they're building up a body of code that shows that they can solve problems in the workplace, so that eventually what they can do is send an email from the VRTA out to an employer saying, not only am I interested in working for you, Amazon or whoever, but I actually have a body of work that's relevant to you. They can send the email, the HR person can open up the email, click the link, open up this simulator with the student's code, run it and see, okay, not only do they have the right credentials from the right schools, but it turns out that they actually know something that's relevant. And so instead of going on the not qualified pile or on the qualified but pile, they can go on the qualified and they proved it pile, which kind of hopefully fast tracks them into more employment opportunities that they're interested in. So that's kind of an example of the robotics and automation thing. We also have an autonomous vehicle that navigates a maze. We're coming out with aerial and aquatic drones, Raspberry Pis, robots that are more tuned for kind of old-fashioned robotics challenges like FIRST Robotics or VEX would have. So the sky's the limit, and we're constantly coming up with new challenges, but that gives you kind of an example of how that works. The final piece I'll just talk through, but for those of you who know, we are a Cisco Net Academy partner. As a result of that, with Cisco's blessing, we have solved one of the big problems that we see certainly at the elementary and secondary level with Cisco, which is this stuff only runs on a PC and the schools are not interested because they're already 75% Chromebook and they're not going to stop until they're 99.9% Chromebook. I don't know what's going on at any of your schools, but my guess is over time, it's going to be more Chromebook style devices rather than fewer. Even in environments where the PCs are available, it creates an enormous IT bottleneck for installing and maintaining and supporting this stuff. And in the case of asking students to install this, I mean, I've seen people who know what they're doing take 2 days to get Packet Tracer up and running. So there's a number of different potential pain points, and different schools will experience some or all of them. And previously, Cisco's answer to, can we have this in the cloud, please, was no. And now Cisco's answer to, can we have this in the cloud, please, is yeah, go to VRTA. So this is an example of the 8.1.2 lab from their Networking Essentials course. This is Cisco's lab. And when I launch the simulator, assuming it doesn't give me demoitis, this is going to run an Ubuntu machine in the cloud. It's automatically going to load up Packet Tracer, and it's going to load the PKA file for this specific lab. And so we have all of the labs for their Networking Essentials, Cybersecurity Essentials, and IoT Fundamentals courses. And we can do, this is the joy of going into simulators too fast. It only lets me have one at a time. But you can see my point. We're loading up the new simulator. It's automatically going into the environment. The student can do the work in the cloud. The results are saved in the cloud. And this means that being tied to a specific machine that will, a specific machine that's been pre-configured for this becomes a thing of the past. And again, as we see, sorry, what's happening is it only lets each user have one simulator at a time, and it's still shutting down the last simulator that I used. Most users don't go through things so quickly, but it's the joys of doing a demo. And that also gives you an example of the fail state. So the fail state when this is running locally is call IT and get in line. The fail state in the cloud is close the browser window and open it up again. because all of these things are automated. It's automatically scaling, and so we can support users coming in at any time of day. There's essentially no tech support calls because, wait 2 minutes, launch the simulator again, and you're good is the answer to 99.9% of all problems. And so if the concern about deploying Packet Tracer or any of these other tools is the support burden is virtually eliminated on a platform like this. So that's plenty of me talking. I will get everybody's faces back up nice and large. I thank everybody for their attention, and I'm happy to answer any questions or take any feedback that you have.
Well, one thing I want to mention, Graham, when you showed us this, that's very important, is that the robotic simulator software you're using is the actual software that's used in businesses to write programs before it's deployed to real robots. So the students actually using the actual simulators that they will see when they go out in the real world before they actually can touch that $1 million, 3-axis robot. And that's what really impressed me, was that ability to see that with robotics. And I mentioned one of the things I put in there is that with the Python, I see that as a good complement to the Programming Essentials in Python class, and the Packet Tracer that they have. There is a Packet Tracer pod that you have for NetLabs Plus if you own a system, but if you don't, this is a great alternative to allow you to do that with Chromebooks and those types of things. So I really like the fact that they're working with the same software on the simulation side for robotics that they will use in the real world.
That's a good point, and that's something that we did deliberately. So one of the points here was, especially at not so much at the college level, but especially at the secondary level, there's a lot of kind of artificial tools that are used because they are easier to teach with. So programming in languages like Blockly, for example. Now, Blockly is a great introduction, but there are 0 jobs in the world that use it. And the problem is, okay, once you're done with Blockly, what next? And what we're trying to do is create a ramp and saying, we want to move into real languages. We want to move into relevant languages. Like there are a number of schools in the world that are still teaching things like Visual Basic and Flash, because that's what the teachers know. But there are 0 jobs out there that are going to be making use of 0 in the case of Flash, very few in the case of Visual Basic, that are going to be making use of this. And what we're trying to do is, as much as possible, give students the tools and the languages that are going to be directly applicable when they want to go to work.
Any questions for Graham about the system? I will tell you, I put the link in there. You go there, poke around, kind of look at it. There is they do charge on a per student basis, I believe it is, Graham and Kyle, but it is their costs are very cheap. It is, like I said, we looked at it, and from a pricing standpoint, it's definitely competitive, no doubt. And in, like I said, a lot of ways they're doing some things that I haven't seen done anywhere. Can we purchase individual basis? Yes. And in fact, there's a way very soon, I think Kyle was talking about, the B2C, business to consumer, is going to be up and running to where for a price per person, you can actually get it. I think it's $12 Canadian is what was the current price. So
yeah. So
the current.
That's coming up very soon, and that's kind of the retail price. And the model is essentially Netflix. It's a subscription, and while you have a subscription, you have full access to everything. So there are no hidden paywalls internally, and when new content comes out, you have access to the new content. If a subscription lapses, nothing is deleted. You're just kind of locked out until you pay again. So pretty standard. So for individuals kind of wanting to try one thing at a time, that's a possibility. If you want to do this at scale, the education institution prices are considerably cheaper than retail. And so, like you don't have to you don't have to multiply the retail price in order to put this in a class. That's the sort of thing where you would reach out to us, and we basically figure out how many students you want to do and put a deal together for you.
Yeah, excellent. By the way, just right now, $1 Canadian, 0.8 US. I wish if the pandemic wasn't still going on, we usually travel to Canada every Christmas or every other Christmas. So I wish that we could go this Christmas, because that's a nice deal there. So any other questions about the system or about what it can do? I think Graham just scratched the surface of all the different items that are available inside the system. There are a large number of labs and things available. So it's definitely, he just scratched the very top of the surface of it. Okay.
Tanya
Tanya,
has
have
one
another
more question.
Yeah, go ahead, Tanya. And feel free to take yourself off of mute if you want to. And
Okay, I will.
okay.
On a per student basis, like let's say we bought 20 licenses, would that be like for any 20 students, or would each student have to have an individual license? Does that make sense?
I think so. So the normal way we would do this is we would do licenses kind of by the user, by the person. Now, the
Okay.
advantage of that is if you had a student that wanted to use the VRTA for more than one class, you wouldn't need to buy it twice. So that if a student has access, they could use it in any number of classes without having to buy again. Normally with what we would do is there's kind of two basic prices. One is essentially a 2-week boot camp, which is $5 a person for 14 days. And under that, the student uses it for 14 days, and then their kind of account lapses. The other pricing model is 10 months, so basically the full school year at $25 or $2.50 a month. So those are the kind of two standard pricings. Now, are we willing to discuss pricing? Yeah, of course we are. But what we think is that, we've squeezed most of the fat out of the pricing to begin with. We think we're very competitive, and we're hoping that, if we're not exactly where we need to be for your institution, that we're pretty close.
Thank you.
Thank you, Tanya. And we have another question Deborah typed in. What are examples of some of the cybersecurity topics?
For that, yeah, so for that, right now we've taken 3 of kind of more of the introductory Net Academy courses. Intro to or networking essentials, cybersecurity essentials, and IoT fundamentals. And basically all of the labs that are simulatable, which is a word I just made up, exist on the VRTA. And so the idea here is that out of respect for Cisco and Net Academy, we're not trying to steal their lunch. And so if you're using Net Academy, the idea is you can keep using Net Academy exactly the way you are now, except that when you get to normally when you get to the labs on the NetAcad side, there's several pages of instructions on how to get Packet Tracer up and running, and best of luck. And when you get to those parts of teaching, you can just skip all of that and say, just go over to the VRTA, look up the lab code and do it. So the idea is that this is a quality of life improvement for schools that want to continue to get the benefits of the Net Academy, the certifications, the fact that this is vetted by the 800-pound gorilla of this stuff, but are getting stuck on the lab portion. That's really where we're coming in. So on cybersecurity, we deliberately don't act as the expert here, because who are we to tell Cisco they're doing it wrong? What we're doing is we're looking at a pain point in Cisco's kind of teaching process and kind of focusing in on the pain point and leaving the rest of it as is.
Excellent. Thank you. Any other questions for Graham or Kyle?
Connor has one.
Connor says, what are
Yeah.
some examples of AI algorithms that can be applied to the robotic simulators? For instance, pathfinding, reinforcement learning.
Good question. So first, I mean, in general terms, the nice thing about Jupyter is it's full Python. So in principle, any valid Python works. Now, in practice, machine learning in some of the examples that I showed you might be a little bit of overkill, and like the code would run, but might run slowly, because once you get into AI, you get into, or machine learning, you get into processing cycles where, the code would execute, but might take some time. This does hint on a longer subject, which is that we are not done making content. And a big part of, there are really 2 groups of people that we're constantly wanting to talk to about what the roadmap is like. So we've got our own roadmap because we have ideas, but we're constantly talking with industry and with educators to try and basically steer the roadmap in ways that are going to be useful. So when we talk with industry, what we're saying is, you're telling us that there are not enough graduates coming out who are ready to go work for you. Help us identify tasks that you would need them to do, let's make simulators and let's bring that down to the post-secondary and even the secondary level, excuse me, and get them exposed to this stuff years earlier. Like, let's solve that problem that way. The other group we're talking to is a group like you saying, okay, what are some pedagogically valuable kind of teaching environments that you kind of have to do abstractly, like, watch a video or whatever, but it would be much nicer if they could actually simulate it. So instead of seeing a video on a trolley problem or some machine learning issue, could we actually have a simulated environment where the students could actually play around with that? And this is something where we will never have all the ideas. We probably won't even have the best ideas. But what we do have is a platform when the idea is kind of gelled, we have the ability to slot that in very easily. Part of why our simulation tool is so powerful is that the LMS thinks of the simulators as black boxes, which means they can be developed kind of in isolation on their own. The short version is, if you can run this on a Linux desktop, we can make a simulator out of it. There's a couple of asterisks around there, but that's generally true. And so if you either got an idea in your head, or you might even have something that you're running, but it only runs on one machine, and you're interested in actually, if I could solve the deployability problem, this could actually be something that could be really useful. I could give it out to a lot of students. These are the sorts of things where we're very interested in having kind of active discussions. We're interested to see what you're working with, what's not working, wish lists that we could put on for ourselves, like all of that stuff. We want to have an open dialogue.
And I will tell you folks, that's one of the things that impressed me the most about them is their willingness to look at taking what they currently have and expanding it to what is needed by the schools. And that idea too, that like you said, for the cost they're offering this, it's cheap enough and they're adding content that it's something that's worthwhile as an additional thing for your students, I think, personally. So that's why we want to bring them here to let you get a introduction to it. So any other questions? All right. Well, what I'm going to do then, Graham, Kyle, do you have any other thing you want to add before I stop the recording?
I don't, other than to thank everybody once again for their time today. I really appreciate it.
And remember,
Great. Thank you.
VRTAonline.com is the website that you can go and look at the information. And surely there's a contact button too. You can contact, and it will get you in contact with Kyle or Graham, either one. And
yeah. So I put in Kyle's email, because if you want a faster response, email Kyle.
Yeah, Kyle's quicker to respond there. So, all right, I'm going to stop the recording.